The last thing we need to look at is confidence intervals. Now, you have to remember the population sampling we expect it to look like a normal distribution, which means we convert anything that we take to a standard normal distribution. Remember, to convert anything to a standard normal distribution, we use x minus the mean all over sigma. However, because we are looking at this in terms of the population, we need to replace these and have a look where it is. So, if we want a specific z-score to be within confidence interval, we want 0.9, let's say 0.95, right? We need it so that sample size we pick is within that interval. Now, if you think about it in terms of a normal distribution, that looks funny. Let's try it again. Like that. We want it so that it's within the z-score, where you have the mean here. This is the mean plus however many standard deviations based on the z-score. And then this one is the mean minus however many deviations based on the z-score. So we need to look above and below mean over sigma. If we rearrange this to get the accuracy that we want, we need it so that our probability of success is based off our sampling plus or minus z times sigma. This then gives you the formula above. Well, formula on the next page. Okay, so the 20% of people in your there are 20 people in your class and 25% are planning on buying the lunch. Estimate the proportion of school population that will purchase the lunch today. Find a 95% confidence interval in your estimate, given that z is equal to 1.96. So let's firstly write down what we know. We know the sample size is 20 people, and the probability of success 0.5. Whoops, not probability of success, the sample size. And we want z to be equal to 1.96. So firstly, we need to find z times sigma, in which we have z being 1.96 times sigma on the right side, which is 0.25, 1 minus 0.25, all over the number of people, which is 20. This then gives us 0.1898. So, for us to get a confidence interval, we need to find p hat minus z sigma, and also p hat plus z sigma. Putting this in the calculator, we get 0.0602 and 0.4398. Now, what does this all mean? Well, the confidence interval tells you approximately what amount of people in a percentage would actually, in this case, buy lunch. So you have approximately 6% here and approximately 44% here. That means you can be confident that 6% to 44% of people would buy lunch today. Okay, Paul samples 102 people and finds that 18 of them like drinking coconut milk. Estimate the proportion of the population that likes drinking coconut milk. So we have the total sample 102, probability of success 102, which is then 0.196. 0.18. So now I want 99% confidence interval, which means if you have a normal distribution like this will be 99%. But remember, our z-scores, or any score that you find for a normal distribution, doesn't calculate anything in between. So you need to find it so that you have the probability of success up to either this point or this point. So you either use the left end or the right end. So what we're going to do is we're going to say the tail end is on the left, so we want to find out this point. Now, because this is 99% in the middle, each side of this will be 0.5%. So if you want to stop at this end, from the left to the right, would then make 99.5%. If you use the inverse normal, you can find where this point is, which then gives you z equals to 2.58. Putting this in like before, z sigma gives us 2.58 times the probability of success, 1, well, what happened? 1 minus 0.18 over n, which is 1/2. This then gives us 0.098. So then looking at our confidence interval, that would then give us from 0.082 all the way up to 0.278, which then means our confidence interval this time will be between 8% to 28%. While people would actually like drinking coconut milk. Okay, we're well 95% sure that 30 to 40% of shoppers prefer their mulch. What sample was needed for this level of confidence? So a confidence level is 95%, which means we want 95% in the middle. Means again you have to calculate up here, because it's 95%, this is 2.5%, which then gives you 97.5%. That means using an inverse normal, which is the z-score of 1.96. Then, if you want 30 to 40%, you then must have p hat to be halfway, because remember you do p hat minus z sigma p hat to give us 30%, and p hat plus z sigma gives us 40%. Because this is halfway in between, p hat must be equal to 0.35. And putting all of this together, putting this into the one, we have 0.3 equals to p hat minus z sigma. And because sigma is this p, which is 0.35, 1 minus p over n, we can then solve for n. If you put this in the calculator and you solve, you should get 349.586, which obviously we need people, so it should be 350 for our population size. Not population size, almost at the wrong.